It is easy to find the slope of the straight line. Merely use the process of the rise over n. However, the same cannot be applied for a curved line. Instead, the slope is the slope of the tangent line. To find it, you must derive because derivative is slope. The definition of derivatives is as the limit of delta x approaches 0, fx plus delta x minus fx over delta x. For example, to find the slope of the function fx equals 2x squared plus x minus 1, you insert the equation to fit the definition of derivatives. And if you want to find a slope at this particular point, for example, at the point 1, 1, you insert the coordinates into the obtained derivative to get the exact slope value. Thus, the same for the point 2, 4. And if you wanted to write out the equation of the tangent line, simply find the points and slope and put into point-slope form. Here are a list of trigonometric, log, and exponential functions. Here are trigonometric identities which can be used to simplify functions. Product rule is the formula to find the derivative of two products. You would multiply the first function times the derivative of the second, add it to the second function multiplied by the derivative of the first. Quotient rule is the formula to find the derivative of quotients by multiplying the second function by the derivative of the first and minus it by the first function times the derivative of the second, all over the second function squared. Chain rule is the formula for finding the derivative of the compositions of two functions. Derive the first function with the inner function unchanged, and then multiply it by the derivative of the unchanged layer. Second derivative is the derivative of the first derivative. It defines the rate of change of the rate of change of position, which is concavity. When positive, that proves that it is concave up, and when negative, it is concave down. The inflection point is the exact point of change for concavity. And for the higher order of derivatives, it is merely the derivative of the derivative. When equations cannot be simplified to slope form, or does not define y as a function of x, you use implicit differentiation. dy dx merely means the derivative of y in respect to x. So to find the derivative of x squared plus 3xy plus y squared equals 1, you would merely use implicit differentiation.